All right, here we go. Sydney's got her hand up. Let's go, Sydney.
Number 14. On the very back.
Here it is. Number 14, you say?
Yes, the word problem on the back.
All right, let's look at number 14. All right, so we have a plane track. All right, so the plane is 331 miles an hour and a course of 190 degrees. Okay. And then the wind is 28 miles an hour on a course of south 17 degrees east. I'm going to do some work with both of those. But that's the given. And I want to find the resultant actual speed and direction. Okay, what is resultant? How do I get to X? I sign this up. So I am going to find the components of each of these vectors. I'm going to draw a picture of the plane. The plane is 190 degrees, so that's a course, a bearing. So that is like this, right? So what would that angle be in standard position? Because if I am going to use x equals r cosine, y equals r sine, I need to have standard position. So what would that be? Can we figure that out? Sydney says 260. Do you agree with her?
Yeah.
I think so, because if this is 190, isn't that little angle 10? And we're going all the way around almost to here, so 260. So my plane's components are 331 cosine 260 and 331 sine 260. All right, you with me, Sydney?
Yes.
Now I'm going to do the same thing for the plane, or excuse me, wind. The wind is south 17 degrees east. East. So point south and then go 17 degrees to the east. So what would his angle be in standard position? 287. So this is the plane, here is the wind, 28 cosine, would you say 287? And 28 sine, 287. Now, what did we say we want to know here? We want to know the resultant. So we said atoms, right? So we're going to add them, and x is going to be something, and y is going to be something on my calculator. Make sure you're in degrees, not sure how you are. So 331 cosine 260 close parentheses plus 28 cosine 287. For x, I got negative 48.29, but I'm going to let you double check that. 331 sine 260 plus 28 sine 287. And I got negative 352.75. How do those coordinates look to you? Does it look okay? All right, so that's not the answer to the question. We gotta go, okay, this is what we started with. We converted it to coordinates. So we ended up with coordinates, but now we gotta convert it back. So let's look at what we have. We're over and down, so we're over 48.29 and down 352.75. This is a picture of these two combined, okay? These two put together are gonna give me that, okay? Now, I need to know the magnitude, which is the actual speed of the plane. So that's gonna be easy. What am I gonna do? Find the hypotenuse, which is just gonna be the Pythagorean theorem. So I got 356.04. So the actual speed of the plane is 356.04. Now wait a second. That's faster than the original was.
I think. I think
They're going both south, right? So it's pushing it a little bit. All right, let's find that angle. I'm gonna find this angle first. That will not be the heading, I know that, but I'm gonna find it. So what is that angle? How will I find it? Second tangent, 352 I turn it on first. Second tangent, 352.75 divided by 48.29. I got this angle to be 82.20. Now, the actual heading, remember, measures from due north, will be this. So what's that green thing gonna be? 270. I got 187.80 degrees, basically. Did you get that? Perfect. All right, Cindy, does that answer your question?
Yes,
All
thank
right,
you.
a lot of work there, but it's easy. None of it's hard. You just gotta watch that angle stuff. That's when we get confused. Okay, who else?
Can you do 5?
5. Change this into a polar equation in graphable form. Okay, so what graphable form means is that it's ready to put into the calculator, which means it has to look like what? If we're gonna put it in our calculator to graph it. R equals, it's gotta be R equals. Just like in regular, in function mode, you have to do Y equals, it has to be R equals. Well, let's see what it is first. X squared plus Y squared plus 6Y plus 9 equals 9. Does that make sense to everybody, what I just did? Okay, so a couple of really good things happen. First of all, the 9's disappear. And second of all, what's X squared plus Y squared? R squared. So now I have R squared plus 6Y equal to 0. What's Y? So R squared plus 6R sine theta equals 0. Now remember, R is a special variable. I can actually divide by it, right? So R plus 6 sine equals 0. So R equals negative 6 sine theta. If you were to type that in, we don't have time to do it, but if you were gonna type that in on your calculator, you would get a circle centered at 0, negative 3 with a radius of 3. That's the equation of that circle. All right, Liz, all right?
Yeah.
All right, who else? Let's go. Yep,
Can you number 20, please?
20. Find the cube roots in standard form. All right, this is the very last thing we talked about in the chapter. This is de Moivre. You need de Moivre's theorem to do this. Cube roots means 1/3 power. So to raise that to the 1/3 power, we're gonna need to get it in polar form. So the number I've been given is -4 root 3, and I need the polar form of that number. So what do I need? R, which is going to be that squared plus that squared, square rooted. That's a special triangle, so it's gonna be 8. And can you tell how big this angle is? You can type it in on your calculator, but you don't need to. That angle is gonna be 60 degrees, right? So in standard form, by the way, let's just pause here for a moment. Do you understand why that problem and the airplane problem are in the same chapter? Aren't we doing exactly the same thing? Isn't this the speed of the plane? And that's gonna be the course of the plane? Yeah, they're the same problem. Now, we didn't cube root the plane, we're cube root this, but the setup is the same. So, this is 8 CIS what? What is my angle in standard position? 240. And that is the number that we're going to cube root. You guys, you've got to remember that this is not an answer. This is the problem. Now we're going to cube root it and get the answer. 3 of them. So what's the first answer? Use de Moivre. De Moivre says 8 to the 1/3 power, which is 2. 240 times a third, which is 80. Now there's 2 more answers. Radius will be the same, R will be the same thing. How far apart are these 3 answers? 120. So if the first one's 80, the second one will be 200. Now be careful, oh no, you said 120, right, so 320. So I'm good, that's okay, I was gonna get too big. Now, what form are these? Those are polar. It says standard form, complex form, rectangular form, Cartesian form. All those words mean this, A plus BI. So, since the angles are 80, 200, and 320, I have no choice. I'm going to have to use my calculator. So, to get x, I'm looking for x plus yi. That's what I'm looking for. So, to get x, I'll take 2 cosine 80, again in degrees, and I get 0.35. Then I'll take 2 sine 80 and get 1.97. So there's the first one. Sarah, are you following along here?
Yeah.
And then I'm going to do exactly the same thing for these. Okay, only it will be 2 cosine 200, 2 sine 200, and so on. All right.
You have 19.
19, convert to a, already did one like this. What does it mean, right here I'm erasing it, what does it mean to be a polar equation in graphable form? R equals something famous. So 2r cosine minus 3r sine equals 6. I've got to get r by itself, so I'm going to factor it out. So 2 cosine minus 3 sine, and then divide. If you were actually going to type this into your calculator, remember this has to be in parentheses if you're actually going to type it in. Okay, Mary? All right, who else? Finley?
It is 7E.
7E. What's that notation mean, people? We talked about this. Who was paying attention that day? It means the conjugate. And in polar form, what did we sort of discover about the conjugate? R stays the same, and the angle becomes negative. So instead of doing up 3, we go down 3, right? So if our number is 3 CIS 100, the conjugate is going to be 3 CIS negative 100, but the rules for polar form are very strict, so we can't leave it that way. That's what it is, but we can't leave it that way. We have to find a positive coterminal angle for that. So what's our final answer? 260. Yeah.
So you had to add 360, you can't add 180 to that?
180. Why would I add 180?
Well, because Miss, don't we sometimes add 100?
If
Is
we're
that only?
changing the sign on R,
Okay.
and we do not want to change the sign on R in polar form,
Okay.
right?
So 360s when we're changing the sign on our angle.
You just want a positive coterminal angle. It's in the same place as negative 100. So if you think about negative 100, you would add 360, right, to be in the same spot as negative 100. Yeah, yeah. Okay, yeah, Lily?
Can you do 12?
Which one?
12.
12. Solve for Z in complex form. So this is kind of like one we did a minute ago. Remember, complex form means x plus yi. So that's what my final answer is going to look like. And I know that z squared is negative 1 plus root 3I to the 5th. So what's z? I'm trying to find z. What's z going to be? Negative 1 plus root 3I to the 5 halves. You're square rooting, and square rooting means raising to the 1/2 power. Right? Now, we need this number to be in polar form. We're going to use de Moivre. De Moivre works for every exponent. Positive, negative, fraction, every exponent. But you can't use it unless your number's in polar form. So I'm going to change this number into polar form. Here's my R, and here's my theta. Alright, so what's my R? 2. What's my theta? 120 if I'm in degrees. It doesn't say anything, doesn't matter in degrees, okay? Now, that is not the answer to the question. That is simply the number converted into polar form. So that is what I'm going to raise to the 5/2 power. Now, what does 5/2 power mean in terms of raising 2 to the 5/2? What does that mean? Well, there are going to be two answers for sure because you're square rooting. But it's the square root of 2 to the 5th power. So another way to think about it is it's the square root of 32, which is 4 root 2. Everybody okay with that? Tess?
Is that the same thing as doing 5/2 power?
Yep. But I'm going to have to put this back into complex form, so I think I'll want it in radical. But it is 2 to the 5/2 power, absolutely. It means the square root of 2 to the 5th. Alright, so I've got 4 root 2. Now, what is, so I'm taking 2 to the 5/2. Okay, now what does de Moivre tell me to do next?
Multiply by 5 and divide by 2 to
Yes,
find out the
yes.
other
So
ones.
120 times 5/2, I'm going to divide first. 60 times 5, 300. So I took, using the Moivre, I took 2 to the 5/2, got this, and then took 120 times 5/2 and got this. But as Peter said, there's going to be two answers to this problem. Because anytime you root, whatever root you take, that's how many answers you got. So when you square root it, you automatically are going to have a second answer, right? How far apart are these answers going to be? 180 degrees. So if the first one was at 300, now you've got a choice here. You can either add 180 and get 480, which is too big, and shrink it down, or you can back up 180 and say, I'm going to be 120. Either way, it comes out to be 120. Does everyone understand that? Either way? Tess? Somebody tell her, why are we adding 180?
Because you're finding two roots and 360 divided by 2 is 180.
Two roots are going to be 180 degrees apart. Three roots are 120 degrees apart. We talked about that the other day. Okay, that's how it is. So remember that, okay? So if I had 4 roots, they'd be 90 degrees apart. Okay. Now, this right here is awesome, except what is this? These are the answers, but they're in polar form. And the directions, I forgot. I think they said complex. So, how do I find x and y, which is what I'm looking for? X equals 4 root 2 cosine 300 and 4 root 2 sine 300. That's the first one. And then 4 root 2 cosine 120 and 4 root 2 sine 120. So luckily for me, I can do this exactly because 300 has a reference angle of 60. Make sure you're including the negatives now when you're not in quadrant 1. So 4 root 2 times the cosine of 300, which is 1/2. So that's 2 root 2 for that one. And then 4 root 2 times the sine, which is negative root 3 over 2. So that's going to be, let's see, negative 4 root 6 over 2, negative 2 root 6, is that what you got? So this one, 2 root 2, negative 2 root 6. Okay, it's awfully quiet. Are we following along? Okay, same thing with 120, so I'm going to go ahead and draw 120. Now 120 also has a reference angle of 60, so we're going to see some similarities here, I think. So 4 root 2 cosine is negative 1/2. So that one's going to be negative 2 root 2. And then 4 root 2 times root 3 over 2. I think that one's just going to be 2 root 6. And I made a huge error. Well, huge might be an exaggeration, but I made an error. Does anybody see it? Exactly. I wrote these as coordinates. These are the right numbers, but these are supposed to be complex numbers, right? So this is 2 root 2 minus 2 root 6i, and this one is negative 2 root 2 plus 2 root 6i. These are complex numbers, so they got to be written like this. The numbers are okay, the numbers are fine, but the form, this is what they need to look like. Okay, I don't know who asked for that question, but are we all good there? Okay, what else? Let's go. Josh? 15. Determine if V and U are orthogonal. Now, V and U are three-dimensional vectors. You notice that, right? There's 3 numbers there. I want you to stop and think a minute about, first of all, what does orthogonal mean? They're perpendicular, right? They make a right angle. How can we do that? Who remembers in 2 dimensions? Well, absolutely, in 2 dimensions we can do slope, but the day we talked about this, I warned you. I said slope is awesome, but it's a 2-dimensional thing. So I gave you another skill. What was that other thing? Dot product equals 0. When you dot 2 vectors, if they equal 0, if that equals 0, then the vectors are orthogonal. Is that coming back to you? Kids, there is no slope, as in changing y over changing x, in 3 dimensions, because you've got z's. So, we need the dot product, and we've never done it in 3 dimensions, but I bet you can figure out how. How do you do it in 2 dimensions? X times x, y times y, add them up. How do you think you do it in 3? X times x, y times y, z times z, add them up. So my dot product is 6 minus 12 plus 3. Are these orthogonal? No, because their dot product does not equal 0.
What exactly is dot product? Like, what is it?
Well, it gives us the angle between two vectors. It helps us calculate the work. So I don't, it's just a vector operation. Yeah, it's a thing.
Zero.
All right, Tess? 7D. Okay, this is a notational thing. Who remembers what that notation is? That's magnitude. So the question is asking if the number is this, what is its magnitude? So in other words, if you drew that, how long would it be? 6. Absolutely. Isn't this the length of it? Isn't that its distance from the pole? That's its magnitude right there. That's it. So it's 6. 17. All right, Mary, you're next. You had your hand up and he didn't. All right, so 17. All right, so you got the old car parked on the hill. And the hill was 14 degrees. The car is 2,800 pounds. All right, so we have a 2,800 pound car pulling down 14 degrees. So this is 70. Right, so there's all of our angles, and the 2,800 pound car is pulling down, and I want to know what force is going to prevent that from happening. So in other words, here's the car, it's trying to roll down the hill. Your job is to hold on to it right here. How hard do you have to pull on it to keep it from rolling down the hill? Well, can we figure that out? You know, all kind, I probably put too much stuff in the picture. Could we do, is this a right triangle right here? Could we do, tangent? If we did tangent, what do you wanna say, tangent? 14 equals x over 2,800? Is that right? I'm gonna use a tangent. So what do I have? 2,800 tangent. Did you get 698? I hope you're strong. This is a pretty heavy car.
Isn't it rolling down?
Yeah, sure. So this is the portion going back with it. Well, it's only 14 degrees. Right? I mean, 14 degrees is pretty steep when you're trying to hold a car, but it's not like 30 degrees or 50 degrees.
I guess it's not.
I mean, if
it's
it
not
were
falling
straight
Yeah,
down,
it's not falling
if it were straight down, it would be 2,800.
Yeah, it's not falling straight down.
Right,
Okay.
right? Look, Mary,
There's not necessarily one on here, but like there was some on like 6-6 homework and on the quiz. The ones where it's like proving an equation like 4 sine whatever. I just need help with one of
So 4 sine 3 theta.
something like that.
Alright, so I think the quiz was y-axis, I have that paper handy. So, because I don't have my, things memorized, but I gave it to you on the quiz, I thought it was.
Or I think it might have been 3 sine 4 theta.
It doesn't matter. I mean, you might as well do this. So, the test for symmetry is either this or this. So, if this is symmetry for the y-axis. So if you're testing for the y-axis and most of us use this one first, and you try this and it works, you're done. If it doesn't work, then you have to move on and try this one. So this one, I'm gonna plug that in. So I'm gonna have negative r equals 4 sine 3 negative theta. I just plug in negative r and negative theta. So this is negative 3 theta. And what happens when I take the sine of a negative? It goes to the front because sine is odd, and that's what it means to be odd. It means a negative input gives you a negative output. And then the negatives are going to cancel. And we ended up with exactly the equation that we started with. So the answer, or if it said, is it symmetric? The answer was yes. If it said, prove it's symmetric, there you just did it. Now, let's say we give up that and it came out like this. Then that didn't work, so then I would have to do this substitution and see if that would work. Okay, you always gotta try them both before you say no. Tess?
On the quiz, if it was like, on like the fourth
Okay,
one.
let's wait till I hand those back, okay? I think it's easier, we'll hand that back. Sammy?
I have a question about the car one. Why isn't the weight of the car like straight down? Shouldn't it be on the hypotenuse of the...
I thought something about that picture was screwy, thank you, Sammy. So, all right, so here's the 14-degree angle.
It's the hypotenuse.
And here's the car hanging straight, and there's the weight of the car straight there, and there's the force right there. So this is 90. This is 90. No, that's not 90.
I think it is. Yeah, that hill isn't 90, because that's an incline.
The top, yeah, the top wouldn't.
No, that's not 90. This is 90. Yeah, there we go. There we go. That's what I want. Thank you, Sammy. You're right. So, yeah. So this is, okay, here's the car right here. His weight is hanging straight down, but I don't have to counteract that because I'm on this slope. So this is my force. Right here. That's my force. Now, what do I know about these angles? If that's 14, this one here would, because this is, so this one here would be 76, and this one is 14. So I got the right triangle, I'm just finding the wrong part of it. So what function am I going to use now? Cosine 76 equals x over 2800, because this is the hypotenuse of that little right triangle. Thank you, Sammy, you are exactly right. So what is that? Is that a better number? Some of you felt like that number wasn't right.
Less than, it's actually less than the other one.
It's actually less than the other one. Thank you, Sammy. Okay, all right, so here's what I need you to do. Next time, we have, a review day.